birthday today. That's not the birthday of the Earth as being discussed down here, but it is the day that we are reminded, if we need one reminder a year, hopefully we live this way, but to do something good for the Earth, to take care of it. So I encourage you to do something today with the Earth in mind, whether that's recycling an extra bottle, whether that's making sure to, use your reusable bottle, or, take a walk or a bike ride instead of driving somewhere, whatever it is. It doesn't have to be big, but do something good for the Earth today. All right. On Friday, I was not here, and I believe that you had some opportunities to work on your Snell's Law practice questions and also to work on some homework, and it was kind of an open deal. How did that go? What do you need? Do you need things from me at this point? Everybody's feeling good? Okay.
Coach, you know Mark Lowe?
I do.
Send you an email.
Okay, I will check it in a little bit. All right. So this is your opportunity now. So if there are any of those Snell's Law questions that you want to go over, this is the time. If there are any of those homework questions to go over, this is the time. Anything I can help you with?
Can you just go over number 2 on the right side?
Of course. Yeah, let me do it. This one, right? Oops, you can't see.
Is the back 0?
Is the back 0? I don't think so. I did it and I recorded it. Did you look at it or no? We can go over it. Okay, here we go. So if you don't have a calculator out, make sure you have one out just so you can practice. We're going to talk about what's on the quiz after this, and I guarantee you there will be some Snell's Law questions on there. I promise. So you might as well look at it now. All right, so a ray of light in air is approaching a layer of crown glass at an angle of 42 degrees. Determine the angle of refraction. So here is our crown glass. We've got air up here, glass, air. I'm going to tell you, I am going to be a very generous person today. I was just thinking about this as I'm writing this down, saying, hey, I did this before. I was up at 12:15 a.m. on Thursday night recording this on a video, right? And it's up on YouTube, and I told you guys to watch it, right? So I'm just thinking about this right now going, wow, I could have gone to bed an hour earlier had I not done this. Since you guys maybe didn't watch it, maybe did, I don't know. So I'm going to do it today because I don't want any excuses tomorrow. But in the future, if I record something for you, what should you do before you ask the question? Watch the video, right? And I don't mean that in a sassy way or in a snotty way. I just mean in a think about your resources before you say you don't understand something kind of way. Does that make sense? Friendly reminder. Okay, here we go. All right. A ray of light is approaching in the air is approaching the glass at 42 degrees. So you're going to draw your normal line, and then you're going to draw your light coming in at 42 degrees. And then we're going to ask, hey, what's going to happen when this light goes into the glass? Is it going to bend toward or away from the normal? Toward the normal. Why?
Because it's
more dense? What did you say?
Because it's entering more dense.
More dense medium, right? So it's going to come in, it's going to go like this. Okay? So I'm going to go ahead and write down my indices of refraction. This is 1. And crown glass, I'm sure I've got a list here somewhere. Maybe. Where did it go? There it is. Crown glass, 1.52. So this is n equals 1.52. Then I've got n equals 1 again. And so we want to know the angle of refraction when it goes into the glass. And then, oh my gosh, it's a trick question, or not trick question, but a multiple parts question, because then it's going to bend when it leaves the glass and goes into air. It's going to bend which way? Away or toward the normal? Away, right? So it's going to go like this. All right, catch you later.
Yeah.
Theta r. So actually I'm going to number these. That's what I did on the video. It seemed to work pretty well. We'll do theta 1 here. We'll call this theta 2. We know by opposite interior angles, right, that these two angles need to be the same because you've got two parallel lines, transverse going through. You remember this from geometry, yeah or no? Yeah? Yeah? Zoom in. Two lines here, transversal. That means that these two have to be equal. Okay? That's what we're talking about. Yay for our geometry skills. When am I ever going to use this? I'm going to use it in physics. That's the right answer. So that's going to be theta 2, and this is going to be theta 3. So we're going to look for theta 2 and theta 3 given theta 1, which is what we know. So we know theta 1 is 42 degrees. We're looking for theta 2 and also for theta 3.
Bless you.
Okay. This is just one of those sneaky situations where we're going to use Snell's law 2 times. So Snell's law first time, we've got, oops, write it out the nice, super nice way. N1 sine theta 1 equals N2 sine theta 2. On your equation sheet, and in general, we usually use I and R, but because I've got 1s and 2s and 3s, I'm just going to go ahead and continue with that. We'll call, I didn't write these N's up this way, but I'll write N1, N2, N3 for the 3 different media. Okay. Trying to solve for theta 2 here. So I'm going to divide by N2. Divide by N2. And then I need to undo sine. How do I undo sine? Inverse sine. N1 sine theta 1 over N2 equals theta 2. Okay. Again, there will absolutely be a question like this on the quiz. It might not be exactly this question, but it'll be something kind of like this probably. If you do not know how to plug this into your calculator, now is the time to get help with that. Make sure that you have a calculator in front of you. Make sure you know how to do it. This is your opportunity. Okay? Make sure you know how to do this. Depending on what math you're in, you may need to double check and make sure that your computer is in in degrees, not in radians, depending on if you are using radians for something else in math class. Just a friendly reminder there. What do we get for theta 2, friends? $26.1. Does that answer make sense? How do you know it makes sense? We started at 42 and we're getting smaller, which is what we thought should happen, right? So that's a good thing. I would strongly recommend double checking that every time because it's really easy to get these two mixed up. And if you do, then your answer is going to be wrong. Okay. So just a friendly reminder there. And then the second part, same game. So it's going to be N2 sine theta 2 is equal to N3 sine theta 3. You're solving for theta 3. Same process again. So you're going to do inverse sine of N2 sine theta 2 divided by N3 is equal to theta 3. So that one's going to be 1.52 on the top, sine of 26.1, oops, divided by 1 is equal to theta 3. You'll notice if you're mathematically minded and you really like looking at functions and things like that, that this one is going to be, the bigger number is up here on top. So that's why it's going to bend away and be a bigger number than the one it started off as. Okay. How are we doing? Is it making sense? Yeah. Anybody feeling stuck or unsure how to plug this in? I'd be super happy to help you if you need help. Super happy to go through it with you or show you.
The same every time. Like it rounds out to 42. Is it going to be the same thing as entering every single time, or is it just like laid out?
So that's a good question. So Sam asked, well, she made an observation without really maybe articulating that she made the observation. She said, holy bananas, look at this. I see that it went in at 42 degrees and it comes out at 42 degrees, right? Is that just a coincidence? What do you guys think? It should happen every time. As long as your pane of glass or your whatever this material is parallel, then the line in and the line out will be parallel.
Do we know how to do it if it's not parallel?
We are not going to go there.
Okay.
Is the short answer. Yes. But the reason that this works, the way that we know this works is because when you look out the window, like I can see the trees and I can see the, big digger stuff and it's not distorted. It's all exactly the same as it was. Literally all of the light is just shifted over a little tiny bit. Yeah. Does that make sense? As opposed to going in just like this. It's been shifted over. Okay, how are we doing? Question 3 is very similar. The game in question 3, and I don't want to go through the whole thing here unless we really need to, but what's going to happen when it enters the crown glass here? Is it going to bend toward or away from the normal? Or is it going to bend? What's going to happen? What's the angle that it comes in at? 0. And so what's going to happen when it goes into the new material? Is it going to bend? It is not, right? Because it's perpendicular to the surface, it's just going to keep on going. Does that make sense? Oops, you're seeing something. I don't know. This happened to me earlier too, and I don't know what the deal is. That's like weird and amazing. I like wrote something and then it all showed up. It's creepy. I don't know. Whatever. It's not wrong, so I'll just show it to you. So it's going to come in. This triangle here, this little bottom triangle, is a 30, 60, 90 right triangle. You know that this is 90 because it comes in there. This is 60 because that's 30, and we've got to add up to 180. You with me there? If this is 30, then this, or excuse me, this is 60, that's got to be 30. Okay? So the angle of incidence coming out of the crown glass and into the air is 30. Is it going to bend toward or away from the normal coming out?
Away.
Away. So it's going to be a bigger angle. So that's all we're talking about is n. So this, I'm sorry, this is the first one. Boop, boop. The second one will be n. So we call this n1, n2, n3. This is going to be n2 sine theta 2. That's 30. And this is crown glass 1.52? Is that what we were just doing? Okay. Is equal to n3 sine theta 3. N3 is 1.0. And that's what you're looking for. How are we doing? You okay? Yeah. Cool. I'm going to pause this for just a second. I want to figure something out real quick. Make sure we're going. I'm going to give you the same question, except I'm going to do one thing. I'm going to rotate this glass. Okay? So same question, but let me draw the picture for you again so that you know what it looks like. So instead of taking that glass like it is right there, I'm just going to rotate it so that it goes like this. Whoop, hi. Like this. This is my 30-degree angle. This is my 60-degree angle. Okay. Oh, you're frozen. You can't see my pretty picture. There you go. Thanks. My light's coming in like this. I want you to tell me what's going to happen. Can do. Same glass, so it's 1.52 still. This is crown glass. I'm going to let you go ahead and work on that for a minute. Draw your pictures, talk to each other, have a conversation, see how it goes.
I got 45 degrees.
You got 45 degrees. So, okay, so let's talk about what that means because I want to make sure that I'm understanding. So what's going to happen when the light hits the crown glass here? It's going to go straight through, right? Absolutely. So it's going to do that just like it did in the other one, right? Same. And then it's going to hit that other surface. I'm going to draw my normal line here. Okay. What's my theta I right here? How big is that? You guys agree? That red angle is 30? What does normal mean? Normal means perpendicular, right? So this thing here is a 90-degree angle, which means that this angle and the red one have to add up to 90. This right here is a right triangle. Are we doing okay so far? How big is this angle right here that I just double marked? That one's 30. So how big is the red one? 60. Okay. I just want to make sure this is making sense to you. So theta I is 60 degrees. NI is, what was it, 1.52? Still same? NR is going to be 1.0. Am I confusing you with the I's and R's versus 1s and 2s? Are we okay there? I means incidence, R means refracted. In some of those other examples, I've used 1 and 2 just to keep them separate because I've got multiple things going on. So what am I looking for here? Theta R? Okay, so if you didn't have that much before, do it now. Set up your Snell's law equation. Figure out what theta R is. Or try. Your calculator doesn't want to do it?
No,
It's like, I'm done.
domain error.
It's Monday. What's wrong? Okay, so let's plug this stuff in. So you got 1.52. So, we're going to do sine inverse of NR. I'm having a really hard time writing today. NI sine theta I over NR. I love that you said my calculator just doesn't want to do it. You're not wrong.
No, it's domain error.
I know it is. Yeah. So what the heck? So what the heck? Sine inverse of what is the thing?
It's like 1.31.
It's 1.31. And my math friends, and I'm not trying to like make other people feel bad, but if you are fluent in the realm of sines and cosines, can you have something bigger than a 1.31 as a value for sine? Has to be between 0 and 1. What's wrong? Did you get a number? So, and I'm not trying to make you like, but I do want to point out, I'm guessing perhaps that the problem was that you switched these two, NI and NR. So NI should be 1.52 and NR should be 1. So maybe when you plugged it in, you switched those, that's a possibility, or you didn't put the right theta in. This does not work, does it? What is going on? I set you up for an opportunity to learn here. So stay with me. What do you think is going on? What's different between this one and the one above? What's different?
In these problems, do you always have to use sine, or can you use tangent?
Nope, it's always sine. It's always sine. Good question. Friends, I set you up for an opportunity to learn here. I want you to turn your brains on. I know it's Monday. I know you had a wonderful weekend running around in the sun. What's different?
Angle of incidence.
You're
It's 60 on the bottom and it's 30 on the top, so it has to be smaller than some number.
some number, right? I want to show you this picture again that we drew before. Do you remember this? Do you remember that we said that if light is going in straight, it's not going to bend? And if it's going at an angle, it's going to bend a little bit, it's going to bend a little bit, it's going to bend a little bit more, and there's a place where it's going to bend too darn much? The reason your calculator said, I don't want to do it, is because it couldn't, because it was bending too darn much. Because the angle was going to be greater than 90 degrees. You with me there? Okay. So if you get into a situation, I don't know, like tomorrow, where you see, let me come back over here, where you get something like this, first thing to do is to double check. Make sure you didn't make a silly mistake like flipping things, okay? But if you're going from a high index of refraction thing to a low index of refraction thing, and you're going in a big angle, then it might not be able to bend that far. It might not be able to refract. If it doesn't refract, what's it going to do? It's going to reflect, right? It's going to reflect. So let's find out what's going to happen. Let's zoom it in. See what's going to happen here. Can I get it any bigger than that? I don't know. That's about as big as it's going to go. It's going to bounce back at an angle of 60 degrees, like this, Yeah, so this is going to be 60. Does that make sense? Okay, which means that this has to be how much? 30. So I've got a 30. We're going to do a little geometry here just because it's kind of interesting and fun. I'm not going to make you do mean, scary geometry another time, but that's all going to be 30. If this is 30 and this is 30, what's that? 120? Does that make sense? This isn't super scary math, I don't think. 180 minus 60 is 120. What's the angle of incidence here then? If this whole thing is 120, how big is that? 30? Okay. Can you figure out what angle it's going to come out at? Are you with me there or no? Did I lose you?
Yes.
It's not going to come out at 30. I don't know. You're going to have to do the math to figure it out. Oh no! Ah! You can do it. There's no need to be scared. This is 30, right?
Okay, where'd you get that 60 from?
Which 60? This one?
Yeah,
Okay, let's back it up. Okay, coming in.
yes,
This is 30, this is 60.
yeah.
It's just geometry, you guys. You got this. Okay. This 60 is true because why? What's it doing? When it's reflecting. Law of reflection.
Always say
Come in, come out.
it's 60 degrees.
60, 60.
All right.
Okay? Then this is going to come in. If that's 60, that's got to be 30.
I thought you just
Right.
said 60.
I just know. It was not random. It was on purpose.
So reflective.
60, 30. If that's 30, that's 30. This has got its whole big thing. This obtuse angle is 120. 120 minus 90 is going to be
30.
30. So you got a theta in of 30. We got this. You can do this. You already did it. But we'll do it again. Here it comes. Theta I is 30. Ni is 1.52. Whoops. Don't groan. Say, thanks, Miss K. If you throw this at me tomorrow, I'll know how to do it now. Right? That's really what you meant to say. I know it was. Oops. NR equals 1.0. Can you do that? Sure can. You just did it. That was the original question.
Okay, so is it just gonna be the same then? 'Cause then you're gonna get the same
No,
answer.
it's the angle.
Not this one.
Oh, it has to.
Oh,
The one, the number,
just
the question number
extended.
3. Your original number 3.
Yeah.
Yeah, except it's coming out the bottom now.
Yeah, okay, so.
Yeah.
So if we get 1.31 sine of 1.31, and we're supposed to find the angle that it exits at, we just say it reflects and then we're done? Or do we?
No, then I would say, like the question would probably say, tell me the path of the light.
Okay, and then we want to find this. Okay.
Yeah, yeah.
So then in that case then, the second, like off the reflections, we get the same one as our top one.
As the original
Yeah.
one. Yeah, what was that angle? I don't remember. I don't think I wrote it down before. You guys wrote it down though. What was it? 49? 49.5-ish?
Yeah.
Yeah? So it's going to come out like this. Yeah. So this is kind of fun, I think. I don't know about you, but I think it's kind of cool because then the light, we know, what? It comes in this way. It reflects, and then it refracts. Look at that. Total internal reflection and refraction all in the same gosh darn problem. Oh. Well, speaking of that, hey, what's going to be on the quiz tomorrow? Let me tell you. 2 sections. Yeah. This should be a G. You were going to ask me a question, though.
Yeah, that was about the last question.
Oh, yeah. Go back.
So
I'm there.
how do we know that, like after the first one, like how do we know then that our first angle of whatever incidence is 30? How do we know that's 30 instead of?
Because it's a 30, 60, 90 piece of glass.
Uh-huh.
This is coming in. The normal is at 90.
Uh-huh.
You with me there? This little triangle here is a 60-degree angle. So 60 plus 30.
So it's just like
So I just want to make triangles. If I don't know.
Make a crap ton of triangles is the right answer. Yes. 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 Use your geometry skills. You guys have all taken geometry, right? Because you're at least in algebra 2 today.
I'm so that's my least favorite.
is that like
Well, welcome to life. Yeah. Go.
is it normal the gray line that we have?
Yes.
So then if we extended that in the corner to be 30, which means that would have to be 30.
Yeah.
It's like if we extend all the way to the corner. Yeah, because then that last angle would
Is
be
that
30,
really
and then it would be
super
alternate interior angles.
Like up here?
Yeah.
Yeah, this would be 30 up here. Yeah, if you wanted to. If that made you happy, then yeah.
Britney Spears.
How are we doing? Great. Okay. Really quickly, because we're going to do a lab today too. We're going to start a lab. Here we go. Here's what's on the quiz for tomorrow. There are 2 standards, 3F and 3G, reflection, refraction, dispersion, total internal reflection. These are all qualitative ideas. So I'm going to ask you concept questions. I'm going to ask you to describe. So we talked about diamonds. We talked about rainbows. We talked about prisms and how they bend light. Okay? And then 3G is going to be the quantitative. That's where the numbers are going to come in. Law of reflection, Snell's law. Okay? Make sense? Okay. Issues, questions, go.
So like conceptual stuff on the top part of it and like on the bottom more math stuff.
Yep, exactly. Exactly. How are we doing? We okay? All right, cool. I'm going to pause this. We are going to go back to the back and get started on a lab. All right, so let's go through that one. So this is, I believe, on page 511. Question number 11. That's the one I'm looking at. So hopefully that matches with what Kaylee's talking about. Hopefully that's a problem that you're supposed to be doing. We'll go through it anyway. A ray of light enters the top of a glass of water at an angle of 36 degrees with the vertical. So we'll go ahead and draw ourselves a glass of water. So this is water. This is air. There's a normal line. Whenever I'm doing a problem like this, I'm going to draw this picture first. Well, not this picture, but a picture that is related to it, right? And at an angle of 36 degrees with the vertical, that's the up and down. So the light is coming in. Like this. Theta I equals 36 degrees. It says, what is the angle between the refracted ray and the vertical? So the first question is the light going to bend toward or away from the normal, from the vertical?
Away.
Away? Do you all agree with that?
Yes.
I hope not. If you do agree with that, you are wrong. If you do agree with that, I feel like that means that we are not thinking this through, and or the last week and a half of what we've been doing is not settling with you. I hope that it's just because you had a really great weekend and haven't thought about it very much and you're just loud, okay? If it's really something that you're not understanding, then you need to go back and study this and understand it, because that is a question that you should know without reservations at this point, because we've done this a bunch of times. We marched it, we've discussed it over and over and over. Friends, I get that it's beautiful outside. I get it, okay? But we're not done with physics yet, so I need you to stay with me, okay? Index of refraction of air or water, which one has a higher index of refraction? Water, right? Air has an index of refraction of 1. Water has an index of refraction of something like 1.33, I think, right? Is that what we had from before? 1.33 stuff? 333? Yeah. Okay. So if it has a higher index of refraction, that means that it is going to bend toward the normal. It's going to slow down because it's a thicker, more optically dense medium. So that means it's going to bend toward the normal. The reason that that's important is because we need to be able to pay attention to that and make sure that we then are anticipating an answer here that is going to be smaller than 36 degrees. It is very, very easy to get this equation mixed up and to plug the wrong things in. And the reason that I tell you that is because I want to make sure every time you do a Snell's law question that you practice it, that you make sure you understand it, okay? So you've got it. So you've got theta I is 36. Theta R is what we're looking for. We don't know. N1, or Ni, is 1. And Nr is 1.33. Those are your givens and your unknown. Ni sine theta I equals NR sine theta R. We want to solve for theta R. Okay? Most of these Snell's law questions are the same darn thing. The algebra here is not super difficult. You just got to practice it. Right now I'm doing NR times theta times sine theta R. I need to undo multiplication. How do I undo multiplication? Division, right? So I'm going to divide by NR on both sides. And now I've got sine theta R, but I don't want sine theta R. I just want theta R. How do I get theta R all by itself? Undo the sign, right? Inverse sine. So I'm going to have the sine inverse of Ni sine theta I. Oops, wrote that backwards. Sorry about that. Over NR is equal to theta R. I want to make sure everybody can do this today. So I want everybody to get a calculator out. Every single person, not just, oh, my partner next to me has a calculator out and they're letting me borrow it. I want you to do it right now on the calculator you're going to use tomorrow on the test, because I guarantee you there will be a question like this on the quiz tomorrow. I promise. Okay?
Pinky promise?
I haven't written the quiz, so yes, I pinky promise. I mean, it might not be a glass of water, but there will be something set up like this. I pinky promise.
Do we need to know the density of it?
The optical density, no. No, I will give you all the indices of refraction that you need. So it's going to be inverse sine of 1 times the sine of 36 divided by 1.33 equals theta R. The hardest part here, the thing that always trips people up, maybe not always, but the most common mistake is flipping these two indices of refraction. And if you flip them, then basically you're saying going from water to air instead of what's actually happening, which is air to water. We get an answer? If you're not sure how to set it up or put it in your calculator, please ask your partner. Everybody needs a calculator out. Every single person. Everybody needs a calculator out. Make sure you know how to do it. There are 4 calculators sitting right up there. Go get one. Or ask Jacob to get you one. I'm sure he'll be generous and do that. Anybody else need one? Okay? Do it. I want you to know how to do it. This is your chance. Make sure you're in degree mode. Radian mode will not work. Unless you convert everything to radians first and then unconvert it. That doesn't sound like a lot of fun. What are we getting for theta? 26? Does that answer make sense to us? Why does it make sense? It's less than the 36 we started with, right? Okay. Does that help a little bit? Okay.
So is it just going to be going from like one to another? Is it going to be one that's like going from one to another to another?
I don't know. I haven't written it yet.
Okay. Because that one, I think we were confused because
We thought that it was going through the glass and
Oh. But it says the top of a glass of water. Yeah.
that's like what I was confused on, like if it did.
Gotcha. Yeah. So you could have,
Then you
you just have to do it again. Yeah. So kind of like question 2 on the green sheet, right? Where it went from air to glass to air. But you could do air to glass to water to oil to diamond to, like, you could just keep going if you wanted. I mean, why not, right? Yeah. All right. Yeah.
It keeps getting denser and denser.
Uh-huh.
Material would just keep going.
It would keep getting closer and closer and closer to the normal, right?
But would it like go past them?
Nope, because it's just going to get smaller. It's going to get closer and closer, right? Closer and closer to 0. Yeah, but it wouldn't ever go beyond 0. Yeah, because that would be a bigger angle. Yeah, does that make sense? Yeah. All right, pull out that green sheet for just a minute because I wanted to do an extension of problem 3 real quick. If you have space on the back for question 3, or you can do this on some notes Wherever you need to do it, that's fine with me. But I wanted to just throw this at you real quick so that you could see it. So this was question 3. This is the one that you hopefully worked on either on Friday or during the weekend. Reminding you here that the light was coming in and it hit the piece of glass at 0 degrees from the normal. So what happens when it hit that right there? Does it bend or no? No, but just keeps going. Does it go faster or slower in the glass than it did in the air? That should be a resounding answer. I'll ask it one more time. Does the light go faster or slower in the glass than it did in the air? Slower. It slows down in a medium, right? It's going slower. The frequency stays the same, but the speed and the wavelength change. Slower in the glass, okay? So what happened here? It went straight, and then when it hit here, then this was 30 degrees and it bent, and then we're good, okay? Here's my extension question for you real quick to make sure that we really, really get this. Here it comes. Same situation. I'm just going to take that piece of glass, and I'm going to rotate it 90 degrees. So here's the situation. I'm going to draw it really big just so that I can see it, okay? It's still that 30, 60, 90 piece of crown glass. So this is a 30-degree angle up here. This is 60 down here, okay? That's a right angle. This is crown glass, so N equals 1.52, I think. Does that look right from your notes, from what you had written down before? 1.52? Awesome. Okay, so here comes my light. It's going to come in perpendicular to that surface. I would like for you to determine the path of the light. Okay, at what angle does it refract out? Okay, so I'm going to give you just a minute to work on this with your partners. Set it up, draw the picture. You can do it.